Well, sixth graders, as we're getting into our new chapter, not even sure what chapter it is, but we're going to be talking about surface area today. When we talk about surface area, I want you to imagine, now this is probably not a great example because this is a rather large box. We have 10 feet this way, 2 feet this way, 6 feet that way. Okay, so we have a box. Imagine the box. We have our three-dimensional situation there. When we talk about surface area, Mr. Swack likes to equate that to if you were giving somebody a present at Christmas time or for their birthday, how much wrapping paper would it take to cover the box that was this size? So basically what we're doing is we're having to find the area of each individual face. Now I want to make a point here. We have 6 sides. We have the top here and the bottom. We have the right and the left. We have the back and the front. Okay? Now I also want to point out this is what we call a rectangular prism, where we have rectangles at the front of the side connected by a bunch of rectangles. And I also want to point out that the left and the right are rectangles that are the same size, or the front and the back are rectangles that are the same size. The left and the right are rectangles that are the same size. And the top and the bottom are rectangles that are the same size. So to find the surface area, I have to find the area of each individual rectangle and then add it together. Now we want to remember that the formula for area of a rectangle is area equals length multiplied by width. We don't want to forget that formula. Area equals length times width. So when I look at this figure here, okay, if I'm going to go to the bottom, I see that it's 10 and 2. So I do 10 times 2, and I think, well, that's 20. But I know that the bottom and the top are the same size. So I have 20 and 20, which together makes 40. So I'm going to write that down. Then I go to the right and the left. And if I look at the right and the left, I see, well, that's 6 times 2. 6 times 2 is 12. So I have 12 square feet here. I have 12 square feet here. 12 plus 12 makes 24. So I'm going to add 24 to my list over here. But then I have the front and the back. And I see, well, that's 10. That's 6. 10, the length, times the width, 6, is 60. 60 and 60 give me 120. And then I have to add all those numbers together. This was the bottom and the top. This was the left and the right. This was the front and the back. 0, 4, and 0 make 4. 4, 2, and 2 make 8. 184. This is area, so it's 184 square feet. We go to example 2. Here we have a square pyramid. So I have a square on the bottom. You can see that it's 11 centimeters on every side. Okay? And then I have a pyramid, so I've got 4 triangles coming up. I have a front triangle, a left triangle, a back triangle, and a right triangle, all going up and meeting at a point right there. Okay, and my height from the bottom of the triangle to the top of the triangle is 14 centimeters. So when I talk about surface area, if this were a box, if this were a present you were wrapping or receiving, I have a square, and then I have 4 triangles around it. Now, since it's a square, and all 4 sides are the same length, what do I know about all 4 triangles? That's right. They are all the same. All 4 triangles are the same size and they have the same area. So if I want to first find the area of the square, square is just like a rectangle, so it's length times width. It'd be 11 times 11. I just square the length of the side. 11 times 11 is 121. So I'm going to write that number down off to the side, my 121. Now I know that I have 4 triangles. As we said before, it's a square, so all 4 sides are the same. I don't need to find the area of 4 different triangles. I can find the area of one and then multiply it by 4. But I need to remember, what is the formula for area of a triangle? Well, if you remember, for area of a triangle, I'll come up here. Area equals base times the height. And we are going to divide that by 2. That's the formula for area of a triangle. So when I look at my triangles here, I see that it's a base of 11 times a height of 14. So I'm going to have to do 11 times 14, and then I'm going to divide that by 2. But I'm thinking, well, I can use that shortcut, okay? I can use that shortcut of dividing by 2. And since this is an even number, I'm going to divide by 2 first. And I'm going to take 14 and divide it by 2. And instead of doing 11 times 14 and then dividing that by 2, I'm just going to do 11 times 7. 11 times 7 is 77. Because I want you to understand that 11 times 7 is going to be half of what 11 times 14 is, because 7 is half of 14. I just divided by 2 first to make that a little easier. Okay? So I do 11 times 7, that's 77. But I have 4 triangles that have an area of 77 square centimeters. So I do have to come over here and do 77 times 4. 4 times 7 is 28. Put the 8 down, carry the 2. 4 times 7 is 28, plus 2 is 30. I've got to take that 308 and add it to the 121. 1 plus 8 is 9. 2 plus 0 is 2. 1 plus 3 is 3. I get 429 square centimeters. All right, let's move on to a couple of other examples. It's a little longer video today, 6th grade, than some of the other ones have been, just because of the nature of this topic. So here I have a different sort of a thing. I have basically a figure. I love these lessons that allow me to show off my artwork that I know that you all thoroughly enjoy. So here, once again, I have a rectangular prism, but this is a little different than the rectangular prism that we saw in example 1, because I see that I have a length of 2.5 feet, I have a width of 2.5 feet, and I have a height of 2.5 feet. They're all the same size. So what this actually is, it's not a rectangular prism, even though technically it is. More specifically, it's a square prism. But a square prism is probably more commonly known to you by what it is called most of the time, and that is a cube. I know some of you like to play with your Rubik's Cubes during class. Mr. Swack needs to ask you to put them in your desk or whatever. So I'm pretty sure that most of you are familiar with what a cube is. Now, what we know about a cube here, since they're all 2.5 by 2.5, all sides are the same. Every side, top, bottom, right, left, front, back, they're all the same. So I don't need to find the area of 6 individual parts. I can just find the area of 1 and multiply it by 6. So to find 1, I see, well, it's got a length of 2.5, a width of 2.5. They're all squares, so I'm going to do 2.5 times 2.5. So I'm going to come down here, 2.5 being multiplied by 2.5. Okay, 6th grade, this is not a lesson on multiplying fractions and mixed numbers. Okay, but we should remember that everything has to become a fraction. 2 times 2 is 4, plus 1 is 5. It's going to become 5 over 2. 2 times 2 is 4, plus 1 is 5. It's going to become 5 over 2. I'm looking for cross-checking. Can't cross-check 2 and a 5 or a 2 and a 5. So I go ahead and multiply. 5 times 5 is 25. 2 times 2 is 4. 25 over 4 is in simplest form, but I would need to turn that into a mixed number. But I'm going to wait to turn it into a mixed number because I have to multiply it by 6. So I'm going to take 25 over 4. I'm going to multiply that by 6 over 1. Why 6? Because there's 6 sides. They all have an area of 25 over 4, but there's 6 of them. So I'm going to come over here. 25 times 6, that's not a difficult problem. That's 150. 4 times 1 is 4. And then I actually just have to go and do that. 150 divided by 4. Okay? Now, what I might want to do is I might want to simplify 150 over 4. I see that they're both even numbers. That ends in a 0. That ends in a 4. If I do 150 divided by 2, all even numbers are divisible by 2, I would get 75. 4 divided by 2 is 2, and that leaves me with 75 over 2. So I can come over here and do 2 going into 75. Well, 2 can go into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. If I bring the 5 down, 2 can go into 15 7 times. 7 times 2 is 14. Put the 1 down. I would have to add a decimal 0. Bring the 0 down. Put my decimal straight up. 2 can go into 10 5 times. There's none left over. I get a surface area of 37.5 square feet. All right, the last one that we're going to do. Thank you for bearing with me, 6th grade. But the last one we're going to do is a triangular prism. A triangular prism where I have 2 triangles. Then I have a rectangle here at the bottom. I have a large rectangle right here. And then I have a rectangle here to the left. Okay? So the first thing I want to notice about these triangles is that the triangles are the same size. They're both 4 and 7, 4 and 7. I want to remember, for a triangle, base times height divided by 2. So base is 7, height is 4. 7 times 4 is 28. I'd take 28, I divide it by 2. That gives me 14. So I have 14 square feet here, 14 square feet here. That gives me a total of 28 square feet. Okay? So my 2 triangles give me 28. Now if I look at this bottom rectangle here, okay, I see that it has a length of 8, a width of 7. This right here is going to be 8 times 7. 8 times 7 is 56. So 56 needs to become part of my answer down there. Over here to the left, I see that I have 4 and 8. It goes up 4 over 8. 4 times 8. 4 times 8 is 32. So I'm going to put 32 and make that part of my answer. Then I have this one right here to the right, kind of at the top. It's 8 and 6. Let me get that 6 in there. 8 and 6. 8 and 6. 8 times 6 is 48. So I need to make 48 part of my list here. So now I got my 2 triangles, made 28. My bottom rectangle was 56. My rectangle to the left was 32. My rectangle to the right at the top was 48 square feet. Now I have to add all these together. 8 plus 6 is 14. Plus 2 is 16. Plus 8 is 24. So I'm going to put the 4 down. Carry the 2. 2 plus 2 is 4. Plus 5 is 9. Plus 3 is 12. Plus 4 is 16. I get 164 square feet. And that, ladies and gentlemen, is surface area for Friday, April 10. Have a good day. We'll talk to you later. Bye, 6th grade.